Okay, welcome back to another episode of my daily integral challenge, and today we're having a look at this fancy little integral, also known as the nightmare of all of my students. What we're looking at here is a typical case for the u substitution. The integral itself is the quantity of x+1 times the square root of x²+2x. It sounds tough to do, especially if you haven't done any substitution so far, but once you grasp the concept of it, it's a pretty neat trick to solve a lot of different integrals. In this special case, we have to use the u substitution to solve the entire thing, basically. And another way we could do would be partial integration. If we take a look at this first part here, we could partially integrate about that one, but I wanted to show off the u substitution because in this case it's really neat. Okay, let's get to it. 3, 2, 1, go. Alright, the first thing I'm gonna do is I am seeing that this part here, if differentiated, leads us to 2x plus 2, y2x plus 2. To get the differentiation of this one, we take the exponent here and pull it into the front and then minimize it by 1. So we subtract 1 from it and we are left with 2x to the power of 1 plus 2. If we only have an x, the x just goes away. That already looks pretty similar to our first part over here. So what I'm going to do is I'm just going to pretend that I have 2x plus 2 in the beginning. So we have 2x plus 2 times the square root of x squared plus 2x. dx. And what I'm going to do now is do a u substitution. I let u with u being equal to x squared plus 2x. And our du, because we also need to substitute the dx, our du will become the differentiation of that x squared plus 2x. So we already solved that one, that is 2x plus 2. And if I look at it, this part here is exactly this part here. That's exactly what I want. However, this integral is not the same as this one, because I just pretended that there was a 2 there. What I'm going to do instead is I'm going to multiply the integral by 1 over 2. Alright, now we're already ready for u substitution. If we're doing this, whoop, I'm missing a dx over here. I should put that there. Alright. If we're doing this, we have 1 over 2 times the integral of, well, I will do something. I will keep it 2x plus 2 here and multiply it by the square root of u. But what am I going to do now? I'm not going to put down the dx or du right away. What I will do is I will take this part here and solve it for dx, so I can actually substitute this dx properly. What I need to do is I need to divide both sides by 2x plus 2. What I end up with is 1 over 2x plus 2 du is equal to dx. And now I'm going to finally substitute it in. So over here I get 1 over 2x plus 2 du. And now something beautiful happens. If we look at it, this part and this just cancel out. What I'm left with in the end is just... Ooh, let me move this over there. Okay. What I'm left with in the end is just 1/2 times the integral of the square root of u du. Alright. As a reminder, the square root of u can be written as 1/2 times the integral of u to the power of a half du. And now we do classic integration. We're going to add 1 to the exponent and pull the rest up to the front. So we end up with 1/2 times u to the power of 3/2, and into the front we pull 2/3. What we're ending up with is just 1/3 times u to the power of 3/2, and now the only thing left to do is a resubstitution, which means we're going to write this as 1/3 times x² plus 2x, because that's what our u is equal to the power of 3/2. And that's actually already integral solved. We can write it a little bit prettier and say this is 1/3 times the square root of x² plus 2x to the 3rd power. Alright, that's the integral for today. I hope you enjoyed this little intro to the u substitution, and I'll stop the timer right here. Okay, if you like what you saw, please leave a comment and tell me what I should integrate or do next, and I'll see you then.